Welcome back, Tulare fans. This video is on real-time traffic configuration. During this video, we'll be discussing the default rules and classes for voice, and if those default rules and classes don't work for you, we'll talk about some recommended configurations and why you'd want to go that route. Prior to viewing this video, we hope you viewed the QoS video to get a good base and understanding of how Tulare does QoS. So let's get started. The defaults for voice traffic, when we see traffic flowing through us that uses an EF tag, it will use a real-time class of 10 to duplicate packets down multiple links simultaneously. So basically, if your switch doesn't strip the tag and your phone places that EF tag on that traffic, we'll dupe it for you. Now, if the switch that you're using, the LAN switch, strips that tag and it's just UDP with no tag, UDP with no tag uses persistent path utilizing only one WAN link. Now, remember, with persistent path, it's sticky to that one WAN link and it doesn't do retrans. And that's from the last video. We'll discuss that a little bit more as we go through the configuration section. So we have these options for the defaults right now. Why would we want to change that? Why wouldn't the defaults work for you, right? Well, hey, maybe you have wrong match criteria. Maybe you have TCP instead of EF or UDP, or maybe it's tagging on a different tag than those. Well, that would be one reason we need to create our own rule to specify. Another reason would be maybe the network environment requires a different setup. So let's say you have an EF tag and you're duplicating the traffic. Well, what happens if you're already filling your pipes and you don't want to duplicate the traffic? You're already at critical mass and you'd rather utilize that bandwidth in some other way. You have too many voice calls right now. Or perhaps your WAN links aren't symmetric. You know, maybe you've got a huge link and then a tiny link, and just duplicating it doesn't make sense because of the amount of traffic duplicating. Why wouldn't you want to use persistent path? Well, there's no retransmits, there's none of that. So what if you had a WAN link that was lossy or unstable? And that really doesn't make persistent path good choices for that. The other thing that we need to take into account is what if you have high volume UDP traffic that'll hit the real-time class and that'll take some of that bandwidth. So maybe something like a NetFlow, right? So we need to think about those things and have it break out. Just because it's UDP traffic with no tag, you know, we can't differentiate the voice unless we have some extra match criteria there. So these are some things to think about as we go through the configuration, and we'll go through our configuration next, going from most preferred and work our way down and why we would use those. All right, so let's get started here in a second. So in this configuration, the user is not going to be using the default EF tag to match on. He's going to be creating his own match criteria. Perhaps, you know, the user knows the subnet and doesn't know whether it's UDP or TCP or, you know, what the match criteria is. And we'll forgive the user for this time since they didn't obviously don't know how to use the Tulare and how easy it is to find that information out. So for the sake of this drill, we'll run through it. But they have a voice subnet, and their voice subnet is 10.10.10.0/24. And as you can see, we easily got, this is coming back to the QoS conduit default set we had created prior in the prior video. And we could do this in the local box as well if we wanted to, but I just put it in the conduit default set. QoS, we had renamed it, and under rules, we created a new one. Any source and any destination from that voice subnet. And the match criteria is irrelevant. Really, it's going to be how we treat the traffic. The match criteria is going to depend upon the network. So our preferred number one go-to for voice is duplicate paths. That's where we base that EF tag out of. Now, with retransmit lost packets off. Duplicate paths is wonderful in a lot of respects. If you're going overseas, it's a must. You could do persistent path as well, but the high latency is great for that. It's just great in a lot of scenarios, and it's our number one choice. It's our go-to when it comes to voice traffic. Now you have a lot of options here. We're going to leave everything in WAN ingress. We got to change it to class 10. We'll use the default class 10, and we have a lot of options here, and a lot of options that we're just not going to touch. We're just going to leave them as is. Drop limit, drop depth. This is how much we're going to back up on that class. Duplicate packets. If you had a small link, we could always increase this disable limit and play around with it a little bit to say, hey, we got 2 links. If one link goes away, let's not dupe down the second link. And this is the settings where we play with that. And then large packets, where we do the reassign class down here, right? What's the large packet size? What's the drop depth? And so forth. Now, TCP standalone ACKs and things like that, that's grayed out since we're not, we didn't specify what protocol. But as I said, all this is grayed out. Anything more, I wouldn't recommend messing with it unless directed by support. And that's if these default configurations didn't work. Alright, now we will check enable packet resequencing, because if we're doing duplicate paths or load balance path, that has to be checked by default. If I didn't check it, I'd just get an error and I'd come back here and fix it. Alright, hit apply, and that's going to be duplicate paths. Our next preferred option is using load balance paths. So why would we use load balance paths instead of dupe? Well, there could be any number of reasons. Maybe bandwidth is critical and we've got too many voice calls, or too much of one thing or another. And we need to override that duplication rule on EF. And that's what we're going to do here. So we're going to set an EF rule to be load balance paths. Alright? So that source could be any source, any destination. That protocol could be any. But the DSCP tag is going to be an EF. And the other thing we're going to do is we're going to rebind that flow on change. Now what that checkbox means is if that flow, if that DSCP tag changes once we've matched on that flow criteria, we're going to say, oh, not a match anymore. Alright? And let's break open the rule. And we're going to do load balance paths, and we're going to retransmit lost packets. Now this is especially good for low latency links, and voice is anything under 100 milliseconds is pretty good, so 2.5 round trip times for us. So if those paths are 20 milliseconds, we're looking good on those retransmit lost packets. Alright, well, I'm sorry, the one-way times. Alright, and then we do the class 10. Alright, we're going to leave the defaults to defaults. And then WAN egress coming out of the WAN. This is where we're going to change our hold timer, and we're going to change our hold timer to be 100 milliseconds, and then we're going to hit apply. And this is the rule for an EF if we were going to override the defaults and say, no, not EF, I want a custom. Now remember, I'm bringing this into my conduit default set, which overrides the default set that comes on the appliance. So this would be more preferred. If I wanted something more preferred this, I would go into the conduit within an individual appliance and set it there locally versus this global command right here. Okay, let's get to the next example. In this example, we'll be changing the class and also changing the rule to be persistent path. So persistent path, remember, keeps everything down one link, and if that link should go bad, moves it to another link. And if the first link comes back good, it will still, though, it won't shift the traffic back over. It'll still maintain that one link until that link goes bad. It's sticky. Persistent path is sticky, which is great for dual MPLS and hybrid, but it may not be so great for dual internet links that are unstable or lossy or something of that nature. But the first thing we want to do is we want to create a new class, and we're going to create class 0 as the voice class. Now, why would we want to create the class? Well, if you remember back at the beginning, what if UDP, that UDP default rule, was hitting real time, and so you had some traffic, that high volume UDP traffic that was also hitting real time, but you weren't sure what the traffic was, or you didn't know between what was voice and what was something else. You could break out that default rule from class 10, create your own rule for voice, and just call it class 0. And then we'll do the share. We'll give it that same share there. Alright. Give it a 50. Alright. Hit apply, which is the same as class 10. And then whatever's taken from voice will remain in that class. And then you can look on your class statistics to see how much traffic is still hitting that class 10, or if there is any. And I'll show you where that changes in the config. Alright, so we're going to add the rule, any source, any destination, DSCP, EF, rebind. Alright, and persistent path. Now, the minute we do persistent path, see how retransmit lost packets is grayed out. I'm not able to retransmit my lost packets. I'm just a souped up VPN tunnel. Maybe you want to track performance. You know, there's some statistics you can view in the actual Talari on tracking that. But this is what's going to change here. You'll have class 0, your voice class, instead of going to class 10. Alright? And then with WAN egress coming out of the WAN, you won't hit a hold timer there. No hold timer, because you're not sending the lost packets. You're not retransmitting the lost packets. Alright, hit apply, and now you're done. So thank you for your time and for going over the real-time traffic today. Hope you enjoyed the video, and get to Talari.